Sometimes when we revolve a region around an axis of revolution, we don't have something that is solid. Instead of having a disk, we have a washer. So the washer method is basically the same thing as the disk method. The only difference is that it's a disk with a hole in it. So it's a washer. And if the region that we revolve around the axis of revolution doesn't border our axis of revolution entirely, isn't flush with it, then when we have this solid revolution, it's going to have a hole in it. What I mean by that is, if you look at every single example that we've already done, every time we were rotating about an axis, so here we were rotating it around the x-axis, our region, our yellow region, was flush with the x-axis the whole entire time. Here, rotating about the y-axis, our region was flush with it the whole entire time. X-axis here, we're flush with it. Y equal 4, we're flush with it. X equal 2, again, we border it, we are flush with it, we touch it the whole entire time. If our region doesn't do that, we're a washer. Basically, when we rotate, we're going to end up having a hole. If we have this yellow region right here, and we were to rotate this around the x-axis, notice that this would have a big hole in it. So if you were to just draw this picture real quick, basically, when we rotate this, what's going to happen is, yes, we'll have this yellow region that gets rotated, but everything that wasn't yellow is just going to be a big hole in our solid. So when you have a washer, what you're going to do is you're going to look for an outer and an inner radius. Your radii are always going to be perpendicular to the axis of revolution, and you always have to integrate the outer radius minus the inner radius. So it's always outer radius minus inner radius, outer radius minus inner radius. Our outer radius is going to be the furthest we are in yellow to the axis of rotation, so that's going to be your outer radius. And your inner radius is the closest we are to the axis of rotation for our yellow area to the curve. We have an inner radius and an outer radius, and we always integrate outer minus inner. We'll always integrate outer minus inner. So you're drawing that yellow area just like you did before. And then if you realize that you're not flush with your axis of revolution, you're going to be a washer, and so you're going to try to find the outer radius and the inner radius. The outer radius is the furthest of your yellow region from the axis of revolution. Your inner radius is going to be the closest part of that yellow region to your axis of revolution. The nice thing is that what we learned before remains the same. If you have a horizontal axis of revolution, you integrate with respect to x. If you have a vertical axis of revolution, you integrate with respect to y. And just like we saw before here, so let's pretend that we're looking at this yellow region with a vertical axis of revolution. Again, you're going to have an outer radius, which is the furthest you are from the axis of rotation, and an inner radius, and that's going to be the closest you are to the axis of rotation. Let's look at finding the volumes of the solids generated by revolving the regions bounded by the graphs of the equations about the given lines. For number 6, we have y equal x squared. Y equals the square root of x, and we are revolving this around the x-axis. Since we are revolving this around the x-axis, we know that this is going to be a horizontal axis of rotation, and since it's horizontal, we need to integrate with respect to x. Now let's draw this so we can find our limits of integration and our radius. We have y equal x squared. Now I'm going to draw y equal x squared. That's just a parabola that opens up. And then y equals the square root of x. That's half of a sideways parabola. There we go. Our region is this yellow region right here. And again, we are rotating it about the x-axis. So I notice right away that this is a washer because notice I'm not always touching the x-axis down here. I'm away from it. Since I'm away from it, I'm going to be a washer. I'm integrating with respect to x, so I need to find my limits of integration in x. Well, I can easily see that my lower limit of integration here is going to be x equals 0, but my upper limit of integration, the thing most to the right here, is going to be wherever pink equals blue. If I set x squared equals to the square root of x, and I try to solve this, well, squaring both sides to get rid of the square root, I get x to the fourth equals x. Moving everything over to the left so that I can then factor, x to the fourth minus x is equal to 0. Factoring out an x, I get x is equal to 0, and x cubed minus 1 is equal to 0. And this guy here, x cubed is equal to 1, is just x equal to 1, which means these two curves intersect here at x equal 1. So I know my limits of integration. My limits of integration right now are from 0 to 1. Now I need to find the outer radius and the inner radius. So your radii are always going to be perpendicular to your axis of rotation. If we look at this yellow region, the furthest I am from the x-axis, which is my axis of rotation, is the blue curve. So this is my outer radius, and my outer radius is going to be the blue curve, which is the square root of x, all the way down to the x-axis, which is 0, or just the square root of x. My inner radius is going to be the closest part of the yellow region, all the way down to the axis of rotation. So that's going to be the pink, all the way down to the axis of rotation. My inner radius is going to be the pink, which was x squared, all the way down to the x-axis, which is minus 0, or just x squared. My outer radius is the square root of x, and my inner radius is x squared. Plugging that in, our volume is going to equal outer radius squared minus inner radius squared. First we square this, and then we integrate. The square root of x squared is x, and x squared squared is x to the fourth. Integrating now, and we have x squared over 2 minus x to the fifth over 5, and this gets evaluated from 0 to 1. Plugging in those limits of integration, it's 1 squared over 2 minus 1 to the fifth over 5. And if I plug in a 0, that's just going to be minus 0. So we just need to figure out on a calculator, what is a half minus a fifth? If we grab our calculator and say 1/2 minus 1/5, make that into a fraction, we end up with 3/10. In the end, my volume here is 3 pi over 10. Number 7, we have y equals the square root of x, y equals negative 1/2 x plus 4, x equals 0, and x equals 4, and we're going to rotate this about the x-axis. So the x-axis, again, is horizontal. Since it's horizontal, what we know is that we are going to integrate with respect to x. Let's draw a region so that we can find the limits of integration, and we can find our radius. So we have y equals the square root of x. I know how to draw that. And then we have y equals negative 1/2 x plus 4. We're going to draw that first. This guy here, this is just a line. It has a y-intercept of 4 and a slope of negative 1/2. We go to 4, then down 1 over 2, all the way down. There we go. That is y equals negative 1/2 x plus 4. X equals 0 is also pretty easy to draw. That's just the y-axis. X equals 4 is pretty easy to draw. And that's a vertical line right here. And then finally, y equals the square root of x, the only one that we're missing. We know that's a half of a sideways parabola. And it looks like that. So our yellow region is bounded by x equals 0, the square root of x, y equals negative 1/2 x plus 4, and x equals 4. So be really careful. That region is this guy right here, because that's where you're bounded by x equals 0, y equals the square root of x, y equals negative 1/2 x plus 4, and x equals 4. And I have to rotate that guy around the x-axis. So do I know my limits of integration? Well, x equals 0 is easy to see. This guy here is going to be where pink is equal to blue. Well, since this is complicated sometimes to find, you can always use the calculator to find those points of intersection. So if we were to use the calculator to find the points of intersection, what we would have to do is we would plug in both of those into the calculator. So we would plug in the square root of x, and we would plug in negative 1/2 x plus 4, and we'd hit graph, and we'd let it graph it, and then we're going to use the calculator to find the point of intersection. To do that, what we would do is hit second, and then trace for calculate, and we are going to calculate an intersect, so we're going to hit the number 5. And then it's going to ask you to scroll where they intersect from your first curve. So just scroll where those two lines meet. When you get close enough, hit enter. Then it's saying, where did the second curve? Just hit enter again. Then it says, take a guess. Just hit enter a third time. And then it tells you they intersect at x equal 4, y equal 2. So we can now see that that's x equal 4. We know our limits of integration. Our limits of integration are from 0 to 4. Now, what we need to do is find our radius. Now, we do not touch the x-axis the whole entire time. We're not flush with it. So we know that we're going to have an outer and an inner radius. My outer radius is going to be the furthest yellow region from the axis of revolution. So that's going to be this blue curve, which is negative 1/2 x plus 4 minus the x-axis, so minus 0. So your outer radius is just that negative 1/2 x plus 4. Your inner radius is the closest of the yellow region to the axis of revolution, so that's right here. So my inner radius is equal to the square root of x minus 0, or the square root of x. Coming back over here and plugging it into the formula, we are going to look at negative 1/2 x plus 4, so our outer radius squared minus the square root of x, inner radius squared dx. Again, if you need to, write that guide twice so you can FOIL it correctly. I'm just going to go ahead and FOIL it for us without writing it twice. So negative 1/2 x times a negative 1/2 x is going to be 1/4 x squared, and then it's going to be minus a 2x minus another 2x, so minus 4x, and then plus 16, and this is minus x. Combining like terms before we integrate, we end up with negative 5x plus 16. Integrating now, we end up with, this is going to be 1 over 12 x cubed minus 5x squared over 2 plus 16x, and this gets evaluated from 0 to 4. Plugging in those limits of integration, we're going to write 4 cubed over 12 minus 5 times 4 squared over 2 plus 16 times 4. And if we were to plug in a 0 in place of all those x's, that would just be 0. So we're just going to say minus 0. Let's go ahead and put that into a calculator. So we're going to say alpha y equals, and then it's 4 to the third divided by 12 minus alpha y equals 5 times 4 squared divided by 2. Finally, plus 16 times 4. We hit enter, and we get 88 over 3. So my volume here is 88 pi over 3.